Same exact, yeah, and it's
Hers is pink.
okay.
Yes.
Oh, gotcha.
Thank
Thank you. I wouldn't have remembered that. No, I got it. I want it. Of course, maybe it's too late now because it's 21.
Probably not. No, I think you're okay. It takes a few days.
It takes a few days to grow up. Gotcha. Are we still dealing? Are we okay? Can we collect data?
I'm done.
Let's put some data together. So, finish up, Christina. So what I'm going to do is I'm going to collect your guys' data into Excel, and then we're going to use the TIs. We're going to show you guys a fun TI trick to calculate the average. Because that is going to be very tedious to do, especially as you can see with this keep dealing until you see one of each face. It takes a while, right? It takes a long time, potentially. It might only take 4, but there's some 12s and some 13s and some 10s. I mean, it can take a while. And it doesn't sound to be super rare to take a while. And that's, again, the point we're getting to here. So first things first, let's not do that one. Let's do the first experiment, which was draw until you get a repeat. Now there are only 4 possibilities for this one, right? So if you guys want to, now on the back side of the quiz, we're going to, well, you know what? No, go to the front side. I'm sorry, go to the front side to get your data. Sorry. And then I'll collate it up here, and then we'll put it onto the back side. Because I want you to, we're going to analyze the class's results. I'm realizing now this is. So, raise your hand if it took 2 cards to get a repeat. So, and how many, and show me with fingers how many times it took you 2 cards. So we're on the first data set, first page. Raise your hand, show me with fingers how many 2s you got. 6, 11, 14, 17, 21, 22, 24, 26, 29, 31, 33, 44, 46, plus 6 is 52. There we go. And what Excel will be doing is showing you a graph of our class's results, updating as we go. Okay, updating as we go. 3. So 3 till you got a repeat. So clubs, diamonds, clubs, or diamonds, clubs, or something like that. So with fingers, how many? And then we'll count them up. 6, 9, 13, 17, 19, 21, 27. Very nice. 31, 37, 39, 45. There we go. I'm like, is that 5? 51, 57, 65, 72, 75, 83, 85.
Hey, the one before.
Say that again?
The one before the 2s? I didn't have my data to that.
Oh, well, throw yours in, Michelle. How many you got?
3.
3. 55 then it is. There we go. Cool so far? How about 4s? How many times did it take us to get 4? 4. We got 2, 4, 9, 10, 11, 12, 15, 22, 26, 28, 33, 36, 38. I got Pam. 42, 45, 48, 51, 53. There we go. Good so far? Good so far? And 5. 5 till we got a repeat. So you got 1 of each, and then you had to throw 1 more down to get the repeat. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Did you get my 2? I put my hand up late.
Oh, probably not. 23.
Okay.
And I counted something wrong
Wait,
because it sums up to 216.
Oh, yeah, I had.
And that's okay. I always had wrong. It's me.
I had 2 4s. I forgot.
You had 2 4s? Well, then it gets better. So it should be 55. And I'm only off by 2. And that's okay. I can live with being off by 2. This does not look like the coin experiment, does it?
No.
This does not look like the coin experiment. Look at the coin experiment. These were matched, yeah? These were matched. We predicted that it would be just as likely to take 2 as it would to take 3. That does not look like what happened here, does it? It's not just as likely to get 2 as 3 as 4 as 5. Now why is that? Do you think? Give me some ideas, Brittany, because it's a 243 question, FYI. Go ahead.
More than 2 options, like there was with the penny.
The tricky part is you're now dealing with a 4-sided coin, not a 2-sided coin. And because of those options, hopefully it makes sense as to why this one is so hard to get. Because in order to keep pulling a different suit, you have to ignore 3 of the ones that have already come before. It's very hard to ignore something that's in the majority to get to that 4th suit that doesn't match. So basically, this is getting to 243 territory, I'm going to back away a little bit, and ask a much simpler question. On average, how many times would you have to draw until you got it? So now flip your quiz over. Flip your quiz over to the second side and fill this distribution in. See the until repeat scene distribution right here? Fill in our class results. 55, 85, 55, 23. Yeah. 55, 85, 55, 23. What do you think the average is? Take a guess. Take a guess. What is the average number of times you have to throw a card out until you're reasonably sure you got a repeated card? Say that again. 3.2. Why 0.2? I love that. No. Tell me why I love this 3.2 business, because I was going to say something similar.
I don't know.
Why not just 3? Why not just 3? Oh, think of the balance. I'm covering up, I'm sure you can still see it because it's projecting on my face, but I'm covering up the 5s and leaving the 2s and the 3s and the 4s behind, right?
Right.
If there were no 5s,
Then it
what would the average be?
3.5.
Exactly 3. Because here's why. This doesn't usually happen. This doesn't usually happen, but there are exactly the same numbers of 2s as 4s. Which means this 3 is the balance point directly in the middle of that 3, isn't it? It's got to be directly in the middle because there's just as much on this side as this side.
Right.
But there are 5s, which means,
So 3.25.
like, they're on your face, rule. Where does my hand have to go? A little bit that way to balance it. But now, how much is a little bit? We can manually crunch it by hand. We can. But let's not. I want to show you guys some cool tech tricks to get the average. We know it's going to be to the right of 3 a little bit. If you need more precision, I'd rather you not crunch these using manual techniques. Do this instead. Go to your TIs. I'm going to show you a